Hi everyone, welcome back to my channel. Today we are going to talk about stratified evaluation. Suppose your rack system scored 87% as aggregate, but what is it hiding? Is it performing well for all types of queries or not? Let's check it. When we are looking at evaluation, one number is the most dangerous number in evaluation. So we have supposed to have multiple of them or something that explains everything that is happening. Say our system scores 95% for simple factual queries. Say, what is the delivery time? What is the refund policy? When am I going to get my order? Those are simple queries. But the system only scores 40% on complex multi-step ones. Say, I'm a premium gold member. I placed an order on 17th of this month. When am I going to get my delivery? What is the refund process? That is a complex query. The aggregate comes out to be 87%. So is that right? I don't think so. The users, when they're asking hard question, only 6 out of 10 times the answers are correct. Other times it is incorrect. So the aggregate fails. So averaging may not be the best case for our solution. So we have to look at something deeper. So for this, we have to slice until the problem becomes visible. So we are going to break down our system into two parts. We're going to consider the category of the questions that is being asked and the difficulty. So for category, we're going to divide on, say, delivery policy, then refund policy, then membership policy. So that will divide the type of questions that are being asked. So for each category, we can validate whether the answers that is being generated by the model are correct or not. Next comes is difficulty. We are going to check whether complex questions are answered correctly, easy questions are answered easily. How is it happening? So that when we push our model into production, it doesn't break over there. When we consider combination of category and difficulty, both, I think that's what gives us the edge. That would be the most revealing and most insightful metric for us to look at it. The cell with the lowest score is your highest priority fix, not the aggregate. So whichever one is visibly less, so we are going to work on that. Okay, let's look at an example for a university student portal. So there are 4 query categories: exam schedules, fee payments, hostel facilities. So hit rate in each case is 100%. So we are actually fetching the right chunk that carries the information. Then let's look at the correctness here. Exam schedules 91%. That's good, I believe. Next is fee payment. So here we are seeing 78%, good. Then remaining 22% that is being problematic here. And look at hostel facilities for 71%, but course registration only has 64% correctness. That means the model is failing in 36% of the queries. So we have to take a look at that and fix the course registration and hostel facilities, both of them. These categories need to be fixed. So each failure pattern has a different fix. So suppose there's a low hit rate problem, then that is definitely something up with the retrieval aspect of things. Right chunks are not being found. So maybe we have to fix our chunking strategy or the embedding model or the retrieval approach itself. If we have high hit rate and low faithfulness, then that's generation problem. The claims that the model is making is not from the context itself. So we have to fix the system prompt or context assembly, the way context is being assembled before giving to the LLM. Next, high hit rate, high faithfulness, but low correctness. That means the model is not able to interpret the context that it is receiving. So we'd have to revisit prompt engineering or go back to our golden data set and fix that. So without stratification, we are just guessing where the model is going wrong. With it, we are debugging and we're going to find the root cause and fix that. So slice your eval until actionable insight is found. All right. Thank you so much for watching my video. We're going to come up with more such videos. Subscribe to my channel. Bye.